Welcome back, everybody. This is going to be the first of two parts in my lecture series on solving systems of inequalities. Let's get started. In order to solve systems of inequalities, we need to know how to graph them. So the first part of this series is just going to be about that topic, graphing inequalities. To graph an inequality, we graph as though it were just an equation or an equality with a couple of changes that I'm going to explain here. So let's do an example together. X plus 2y is less than or equal to 8. So to start, we're going to pretend like this just says x plus 2y is equal to 8. And we probably recognize this as a line. So I solve for y by subtracting x over to the other side, and then dividing both sides by 2 to get y equals negative 1/2 x plus 4. And now I can graph this guy since it's in slope-intercept form. The y-intercept is positive 4, and the slope is negative 1 over 2. Negative 1 over 2. And I graph normally. Now, here comes the change. These are the set of all points for which x plus 2y is less than or equal to 8. To find the set of points for which it is, these are the set of points where it equals 8. To find where it's less than or equal to 8, that's everything below that line. And so we shade in that area. So this whole shaded region then would be the graph. Let's try another one. Similar thing here. I'm going to graph it as though it were an equality. Y equals x squared minus 1. And I can graph this guy with transformations. This is just the parent parabola shifted down 1 unit. So I know the vertex is at 0, negative 1. And then I've got a point here and here. But notice this time I don't actually want to include the spots where it's equal. So I sketch the graph using a dashed line this time. A dashed line. The rest of the procedure is the same though. I want the y values that are below this line. So this would be the solution. Not necessarily the dashed line, but the shaded region is the solution. So remember, if you have less than or equal to or greater than or equal to, we use a solid line to indicate the line is actually a part of the solution. And with less than or greater than, we use a dashed line to indicate that the curve is not actually a part of the solution. In this video, we saw how to graph inequalities. In the next one, we're going to see how to use those techniques to solve systems of inequalities. Catch y'all in the next one.